So this is lesson 1, binomial. We're going to start with binomial since all of you said we should start from the first lesson, from the first topic. So lesson 1, this is binomial. And of course, for those that do not know my name, this is my name here. My name is Hamtedi. Yeah. So I'm a student also here at Lubumbashi University, doing mechanical engineering. So we start. So first of all, you need to understand what is a binomial expression. You need to know what a binomial expression is for you to start solving binomial questions. So a binomial expression is just something that contains two terms that are connected by a plus or a minus. And then an example that I gave on binomial expressions are these here. We can see they have two terms, P and Q. And then we can also see to say this also has two terms, 2x and y. And expanding these terms for the integer values of n from 0 to 6 give the results below. So these are the results. So when you expand this expression here with different values of n, this is what you're going to be getting. And when you look at this properly, you discover that there's something that I may call a pattern. And then that pattern is the one that we call the binomial theorem. But we're going to go to that at some time later. For now, let us first just understand this. So we can see that in this pattern, A decreases in the power moving from left to right. So in this pattern, A is decreasing. We can see there's A squared. Here it is now A. And then there we have X. X appears there. Then plus, there's X squared. Same applies here. A is decreasing in powers, while X is increasing in powers moving from left to right. So now this pattern, as I earlier on said, this pattern is also known as the binomial. It's also known as the binomial formula or a Pascal's triangle. Let me just see some messages on WhatsApp. It seems like some are not able to connect. Okay, let's continue. So we proceed. So what you are seeing down here, is what we call the Pascal's triangle. You can see the pattern of the Pascal's triangle. It's just the same as the pattern of all the coefficients in this expansion. So when you look at this one, this is how you form a Pascal's triangle. You look at this one. When you look at this one, you write it there for the power which is 0. And then for the power which is 1, you just get the coefficients of A and the coefficient of X there, which is just 1 and 1. And then when you add 1 plus 1, you are getting these 2 here. Then when you add 1 plus 2, you are getting these 3. Then 2 plus 1, you get that 3 again. Okay. Yeah, you get that 3. And then 1 plus 4, you get that 5. And then 4 plus 6, you get the 10 there. And then 6 plus 4, you get the 10. 4 plus 1, you get the 5. So that is how you form a Pascal's triangle. We move on. Okay. So we have an example here. I use the Pascal's triangle method to determine the expansion of this. So when you look at this question here, it is somehow straightforward because when you go back here, we know to say these are the numbers that are involved in the Pascal's triangle. And then, meaning for you to answer this question, you first have to expand this expression here. Yeah, you first have to expand this expression there. And then the way you expand it, you first don't consider the coefficients. You come and put the coefficients at the end, at last. The coefficients are the ones that we're calling the Pascal's triangle. And these numbers that are found in the Pascal's triangle. So we proceed. So first of all, you write down your Pascal's triangle. When answering this type of question, you write down your Pascal's triangle. And of course, when you look at this, it's just ending at power 6, while our question here is starting from power 7. Meaning there's also, there's a need for us to add another line down here. So how do you add the line there? So you see, you can see that from top here coming down, there is always a 1 that is there. So you write a 1 there, and then when you add 1 plus 6, you get a 7 there, and then 15 plus 6, you get 21. Then 15 plus 20, you get your 35 there. And then 15 plus 20 again, you get your 35. 15 plus 6, you are getting 21. Then 6 plus 1, you are getting your 7. And then lastly, you write your 1 there. So this is how you form your Pascal's triangle. Let's move on. So as I earlier on said, you first expand this expression without putting your coefficients. And how do you expand the expression? Remember what we said when we were just starting. We said the power of A will start with the value of n, which is 7, and then to keep on decreasing, A7, A6, A5, A4, A3, A2, A, until A is raised to power 0. Because we know that any number raised to the power 0, it's equal to 1. So here, the reason why we have not written the A, it's raised to the power 0, which is just the same as 1. So we can proceed. So as A is decreasing in powers, X is also increasing. So when A has the highest power, X will have the lowest power, which is 0. X to the power 0 will give you 1. 1 times A, you get your 1, and sorry, you get your A to the power 7. So this is what you do. And then from there, yeah, this is what I was showing you. You formulate your Pascal's triangle and then get your values. So we did this. This is what we got. Then finally, after expanding this without putting the coefficients, you write it down. Yeah, let me just do this. Yeah, you write it down and then put in your coefficients. So all the coefficients correspond to a particular term. When you look at this 1 here, it corresponds with this A. You multiply this 1 times A, you get your A. Then this 7 times 7A to the power 6x, you get that. So you multiply them in that manner. So proceed. So example 2 is saying determine using the Pascal's triangle method the expansion of 3x, the expansion of 3x minus 4y. So first thing in this expression, you need to identify which one is your A and which one is your B. So in this case, instead of using x here, assume this is B. Because since we have x in the equation there, since we have x here, it will be, since we have x there, it is going to be difficult for, it is going to be difficult for us to say maybe 4y is equal to x. It will seem as if it's an equation. So that's the reason why I'm saying, let me just do this. Point, how is the pointer? Okay, R. Okay. So I was saying this 3x is going to be our A according to these expansions. So the 3x is going to be our A. So I've identified to say my A is equal to 3x. And then I'll also look at this, I'll also identify which one is my B. So my B in this case is going to be negative 4y. So in short, what I'm trying to say here is that where there is A in this expression, or sorry, where there is X in this expression, you just put B, 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 B. Yeah, you continue like that. And then after doing this, you can now start expanding. So you can first make an expression or you can first expand this in terms of A and B. So you're going to have, so expanding 3x minus 4y to the power 4 is equal to, so in this expression, where there is A, I'll put 3x squared. So I'm going to put 3x squared, oh sorry, 3x, and then the power here is 7, but in this case, my power is 4. So I'm going to raise this to the power 4, the highest power. Of course, here my B, or rather my negative 4y, is raised to power 0, which is just 1. And then 1 times that, you get that same number. So we say plus. So plus, you look at this. Your A reduces reduces in power. So your A reduces in power. My 3x will reduce by 1. So when it reduces, I'm going to have 3 there, and then my y is going to be, oh sorry, my B is going to be negative 4y. It will start formulating here. Here now, it's not raised to the power 0, it's raised to power 1. And then we say plus your A, you write your 3 there, 3x. It reduces in power by 1, so we're reducing in power. So this is 4 minus 1, we get 3. 3 minus 1, we get 2. And then this side, we're going to be adding. So here there's already 1. So 1 plus 1, we're going to have 4, 1. And then in brackets like that. And then to the power 2. And then plus. This 3x will also reduce in power again. So this 2 minus 1, you get a 1. And then this negative 4y will increase in power. Negative 4y will increase in power, which is going to be 2 plus 1. We're going to get 3. And then lastly, we're going to raise this 3x to the power 0, which will give us 1. 3x to the power 0, you get 1. And then 1 times any number, you still get that same number. So lastly, you get negative 4y. So you get negative 4y, and then raised to power 4. Then once you simplify this, people are still joining. So once you simplify this, you are going to have something like this. Yeah, actually, so this question is from your tutorial sheet. So these letters I've written here, I just simply means this is question 2 in tutorial sheet. Sorry, not tutorial sheet, but tutorial sheet 1. I just made a mistake. I'll correct that before sending the slide. So this is question 2 in tutorial sheet 1. So as I earlier on said, you first identify which one is your A and then which one is your B. Then after identifying your A and your B, you expand it like that. This is what we're just from doing. Then you introduce now the Pascal's numbers. So you come here. Yeah. So one may be asking, may be wondering, where has he gotten these numbers? 1, 4, 6, 4, and this one. So I'll just go. So I'll just where I've gotten these numbers is I'll go here in my Pascal's triangle where where the expression is raised to power 4, because my expression here is also raised to power 4. Then I'll get all the numbers there: 1, 4, 6, 4, and 1. Then after that, I'll come and multiply them with my expansion. So after multiplying them, you get your answers to be that. So this is going to be your final answer after multiplying them. So as you are going through this slide, before sometimes you even see the actual answer, you should be trying to expand it. You try to work it out and then check the answer at the end. Okay, proceed. So this is example 3 from tutorial sheet 1. It's also question 2 from tutorial sheet 1. So let us expand these two expressions using the Pascal's triangle. So I've already done the first part here. It's the one that we're from doing. Then we now proceed, we move on to the next part, which is this one. So the value of A there is going to be X in this one, in this expression. Our value of A is going to be 6, and then the value of B is 1 over X. And then our N there is going to be 6. So N is just the power of the expansion. So if you work it out properly, this is going to be your solution. So this is going to be a solution. Yeah, on this one, you just pardon me for today. I'll install some application that will be able to write fractions. Otherwise, I was unable to write fractions. I'm using Microsoft 2007. All right, so that's the reason why I decided to just put a picture. So we proceed. So this is going to be a solution for this question, the second part. So as I told you, when practicing these questions, make sure that you solve it on your own and then try to compare the answers. So we move on now. So there are several methods of expanding expressions. The first method that we've discussed is the Pascal's triangle. Then the second one here that we're going to discuss is now the binomial theorem. So a binomial theorem is just a formula for raising a binomial expression to any power without lengthy multiplications. The general binomial expansion of a plus x to the power n is given below. Now, before I show you the general expression for the binomial expansion, I want to explain this lengthy multiplication. They're saying the binomial formula is it's just a formula that is used to expand expressions without lengthy multiplications. Take, for instance, you have 1 plus x and raised to the power 10. If you've been told to expand this, how can you expand it? Huh? Because you have to multiply this 1 plus x you multiply it 10 times, you multiply itself 10 times. It has to multiply itself 10 times, like that, to keep on writing. Now imagine the area of the book that you're going to cover, expanding this using this method, like that, to take you hours for you to finish. And then after even wasting time, at some point you even discover that you find the wrong answer. So that's the reason why the binomial formula is kind of helpful. It's very important. So the formula is given by this. This is the formula here. A plus x to the power n. When you're expanding any expression in this form, a plus x to the power n is equal to a to the power n. So firstly, you write this a, and then you raise it to the power n, this n. And then plus, this is the binomial formula. You bring down this n, and then n minus 1. Remember what we said from the previous lesson, or from the previous example that we had? We said this the power of n keeps on reducing up to until it reaches 0. So the power of a keeps on reducing, and then the power of x keeps on increasing. So don't look at this to be something that you can just master or no, or something that is difficult to master. No, straightforward. You just need to know to say the value of, the power of a will be increasing, or sorry, will be reducing, and then the value of the power of x will be increasing, like that. So this is what is happening. And then remember, every time the powers are increasing, there is also this factorial thing down here. So this factorial thing, the meaning of this is, let's take, for instance, we've been given to find the same 2 factorial. Okay, the same 2 factorial. So 2 factorial is nothing but 2 times 1. This is 2 factorial. 2 factorial is just 2 times 1. So when you've been given 3 factorial, 3 factorial is nothing but 3 times 2 times 1. All right. So this is 3 factorial. So now we proceed. Hope you have understood what it means. What it means by the factorial things. So we move on. So the binomial formula is not only written in this form, it has versions, I would say. So the other version of the binomial formula is this one. And I prefer using this one than the one on top. But if you like to learn how to use this one, it's also straightforward. But the one down here is more simpler than the one on top there. Though it's just the same, it's just that this one has been simplified. Now the simplification makes it a little bit complicated to master. So this is the expression a, as we said, a, the value of n keeps on reducing for a, and then for x, yeah, now in this case, instead of using x, we're even using b. So for b, the value of n keeps on increasing. And then when you've been told to find the n, choose 1. This one is read as n choose 1. So when you've been told to find this, it just simply means that this is what it means. I'll explain. So r factorial, I've explained this. When you have, for instance, r factorial is just 1 times 2 times 3 up to r. For instance, when you have 2 factorial is just 1 times 2. 3 factorial is just 1 times 2 times 3 times, yeah, times 3, that's all. Then 5 factorial is just 1 times 2 times 3 times 4 times 5. So I've explained this. So there are, in each expression that you expand in a binomial expansion, there are n plus 1 terms. So if you're expanding, let's say for instance, you're expanding 1 plus x and then raised. So if for instance you're expanding this 1 plus x and then raised to the power maybe 5. So if you're expanding this, what you should understand is that in this term or in this expansion, you have n plus 1 terms. So the number of terms in this expansion is n plus 1. So if you've been told to find how many terms are in this expansion here, you just say 5 plus 1. So 5 plus 1 is the number of terms that is in that expansion, that is in this expansion. So 5 plus 1 is nothing but 6. All right, we proceed. So this is what they are just trying to explain here. This is what they are trying to explain there. So now I think we can proceed. Okay. So the first and the last coefficients are always 1. This is, we observed from the Pascals triangle to say, let me just go back. Okay. I just want to go back. So that point is saying the first and the last coefficient is always 1. The first and the last coefficient is always 1. So that point I think is straightforward. You can get it from the Pascal's triangle. Yes. And then the coefficient of any term, r plus 1 term is equal to n choose r. So you may be asked to say, show that this is equal to that. These are simple questions. Show that 10 choose 3 is equal to 10 choose 7. How do you solve such a question? So we said, we know to say n choose r. We know the formula for n choose r. I showed you on the previous slide. So 10, this is the question. So 10 choose 3 will just be 10 factorial on top like that. And then over, you write your 3 there, 3 factorial. And then you subtract 10 minus 3, you get your 7 there, 7 factorial. I can see some people are struggling with network, but don't worry. I'm recording the session. I'll send it to you. So this is what it means. 10 factorial, sorry, 10 choose 3 is just 10 factorial over 3 factorial multiplied by 7 factorial. So 7 factorial is coming from 10 minus 3. So this is what you get as your answer. So this 10 factorial, we know to say it's so this 10 factorial, we know to say is 10 times 9 times so this is 10 times 9 times 8 and then times 7 going down there. So instead of writing the numbers below 7, I'll just say 7 factorial. Why have I done this? Because I've seen this 7 factorial down here. I wanted to come and cancel with it. So I'll do this 7 factorial. And then this 3 factorial is nothing but 3 times 2 times 1. That is 3 factorial. So I can cancel out this 7 factorial and this 7 factorial. Then I'll divide this 2 into 8. I'll get my 4 there. And then I'll divide this 3 into 9. I'll get my 3. So when you multiply 10 times 3 times 4, you get your answer to be 120. So if you can't understand at any point, you can't see anything here, or you have a problem or a challenge somewhere, you can send the message. There's a message box on the screen there. Or if you have any question on what I'm doing, you can send the message and I'll be able to read it. Okay. So we proceed. So this is 120. So in short, 10 choose 3 is 120. They have asked us to show that 10 choose 3 is equal to 10 choose 7. So let us also find 10 choose 7 here. So 10 choose 7 is just the same as 10 factorial over 10 minus 7. First, I can write my 7 factorial there. And then 10 minus 7 is 3 factorial. So 3 factorial is equal to, 10 factorial is equal to 10 times 9 times 8, then times 7 factorial, like that. And then over, I'll write this 7 factorial there. Same things. Then you write this 3 factorial there. 3 times 2 times 1 times 7 factorial. So that and that will cancel. Then when you divide everything there, you discover that your answer will also be 120. So this is how we show, or this is how you answer such a question. So such a question was brought by your lecturer, Mr. Matindi, in the tutorial sheet. So hence shown, that is how you show your working. So this is the question that you brought in your question. So the way you solve such a question, there are 2 methods by which you can solve such a question. And then, yeah, there are 2 methods. One is a little bit, I would say, cumbersome, but I have my own method that I use to solve such questions, and it works for me. It's very straightforward. So I'll show you mine, and I've also put a picture for the normal method that you're supposed to use. So what you do here is you first pair the terms with the same value of n. So the same value of n, the pairs with the same value of n, there is 9, choose 3, and 9, choose 2. So I'll add 9, choose 3, except for this one, for this method, you just have to follow certain simple rules. Like that. So then I'll say plus 10, choose 6. So you add a 1 to the power, you get 1, you get 10. Then the same number that you add to the power, you add it to the denominator there. And then the one that, sorry, not a denominator, you add it to this other pair of a combination. So these 2, we're going to get the lowest number between the 2 combinations, which is this 2. So these 2, I add the 1, I'm going to get a 3. So I'll have my 3 like that. And then you have your 10 like that. Choose 6. So I've just brought this 10 to 6 down there. So same applies. You you add a 1 on the top part there. So 10 plus 1, you'll get to 11. And then you look at the down numbers there. The down numbers, the smallest number I have is 3. So when I add a 1 to 3, I'm getting a 4. So this is my final answer, 11 choose 4. So there is also another way which you can do this, which is a recommended way. And I want you to go through it on your own time, but I've solved it on the paper. It's a little bit long. So me solving it here to spend time, to take time. So this is the method that I'm talking about here. So this is the method that I'm talking about here. You can see this. So you first say 9 factorial, you convert this into the factorial format. 9 factorial, then 9 minus 3, you get your 6 there, 6 factorial, and then 3 factorial, plus 10 factorial, 6 factorial, 10 minus 6, you get your 4 factorial there. And then 9 factorial, 9 choose 2, so 9 minus 2, you get your 7 factorial, and then the 2 factorial there. So you expand them in the way that you need to make at least some of the numbers to be common. And according to my expansion here, I made 9 factorial over 6 factorial, 2 factorial to be common, and then I factored it out, and then I remained with this. So this is what I had after factorizing it. Then you solve these fractions in the brackets. Once you solve them, you get this answer. Then once you get this answer, you find ways in which you can multiply, you can make this 110 to combine with this 9 factorial. And how did I do that? It's by multiplying 110. It's by multiplying 10 times 11 here, like this, and then times the 9 factorial there. Same applies to 84. You find numbers that when you multiply them, they are going to give you 84. But despite them giving you 84, they should not cut the what? I would call it the continuation. It has to continue from those numbers to 6 factorial or 2 factorial. And this is what happened. I got 3, 4, and 7. Then this was my solution there. And then after that, you can see that this, when you compress it now into the factorial format to come back to this, then this is just the same as 11 choose 4 factorial. Also 11 choose 4. So this is question 1 in tutorial sheet. This is question 1 in tutorial sheet 1. So we can proceed. So find the possible values. This is question 9. So what I'm doing, you guys, I'm making sure that as we are proceeding together, I'm using questions from the tutorial sheet. I'm using questions from the tutorial sheets as examples so that we shouldn't have maybe to come and start wasting time to go through the tutorial sheet. Instead, I've solved them already in the slide. Okay. So we can proceed. So they are saying find the possible values of x for which the following equation involving binomial coefficients holds this. So these are combinations. You need to know them. You need to know how to work them out. So once you see that the top part there is equal to the top part there, it means that the down part is also equal to the down part on this other side of the equal sign. So what happens is that you just have to equate the down part. Since 8 is equal to 8, so meaning you just have to equate the down part as well. X squared is equal to negative 4. Okay, somebody's raising a hand here. Let me just respond to him. Okay, anyway, Aline, I don't know if, okay, let me check. So Aline, what you do is you can't see anything on the screen. All right, but I'm recording the session. So if it's difficult for you to see anything, I will send the video to the group. You'll be able to understand. And then if you have any questions, you inbox me the questions that you're going to find difficulties. All right. Okay. Please inform me when you begin to see something. Inform me. All right. So we proceed. So I said we just equate the denominators. Also, not the denominators, but the down parts of the combination, like that. And then this is -4. Yeah. This is -4. And then, all right, you have now started seeing something. It's good to know that. So this is -4x and then -4. So what you do here is you just solve this quadratic equation and then find the values of x. Then how do you solve this quadratic equation? First, you bring everything on one side. So it's going to be plus 4x and then plus 4 is equal to 0. We all know, I think, how to solve quadratic equations. So you factorize this. So you're going to have, first, before you factorize, you find the common factors. So you're going to have the common factors to be 2 and 2, such that when I multiply the 2, I'm going to get the 4, and then when I add the 2's, I'm going to get this 4 again. So I'm going to have plus 2x plus 2x plus 4 plus 4 is equal to 0. So now you can factorize like that. So we're going to have x plus 2 and then plus 2, then open brackets, x plus 2, like that, is equal to 0. So now you factorize which one is common there. My x plus 2 is common. And then I'll write the remaining ones, x plus 2, and this other part again. This is equal to 0. So we proceed. So this is saying x. So this one is going to give us x is equal to -2 when you solve it properly. So this is what I did even on the solutions. You get your x to be -2, and that is your answer. Then we have another example, which is example 7 from story sheet 1, question 4. The question was saying, write down the expansion of x of 2 plus x to the power 4 and then 2 minus x to the power 4. Yeah, so now we can start solving it. The way you solve this, you can either use the binomial expression or you can use the Pascal's triangle. You still get the same answers. So you expand that, you get this as your answer after the expansion. Then when you expand the second part there, you get that as your answer. So on your spare time or when you are studying, make sure that when you expand the 2, you get these answers. So the second question is saying, hence simplify 2 plus x to the power 4 plus 2 plus x to the power 4. So if they tell you to add or subtract these two expansions, it's just the same as telling you to add or subtract their solutions this side. So if they say add 2 plus x to the power 4 plus 2 minus x to the power 4, they are just simply telling you to say add these expressions. So I'm going to add 16 plus 16, you get your 32. and then 32x minus 32, you get your 0, so you don't write it. You move on to this one, 24x squared plus 24x squared, you get your 48x squared, and then when you add like positive 8 x to the power 3 minus 8x to the power 3, you get your 0, so you leave it. And then when you add x to the power 4 plus x to the power 4, you get 2x to the power 4. That's going to be your answer. And then finally, they are asking you to use this final answer that you have found to find the exact values of 2 plus root 3 to the power 4. So for this question, you can understand to say, what they are trying to ask you to do here is, when you look at this, let me write this. Okay, yeah, okay, and I've written it here. So when you look at this part, this side, we have a 2 here. There's also a 2 on the right side of the equal sign. So meaning this, if this 2 is equal to that 2, and then the power is also equal to that power, it simply means that even the x's are the same. So meaning our value of x, from just observing this system here, our value of x is equal to root 3. So in short, what they are trying to say is that where there is x in this expression, you just put the root of 3. Where there is x, you put the root of 3. So meaning you are going to have something like this. 32, you're going to have 32, and then plus, yeah, so you're going to have 32 plus 48. You're going to have 32 plus 48x. Oh, sorry, where there's x, you put, where there's x, you put the root of 3. So where there's x, we replace with the root of 3. Like that. Then you square it. Then plus 2, where there's x, you put the root of 3. With that, the root of 3. And then you raise it to power 4. So you discover that you are going to have something like this as your answer. 32 plus the root of 3 to the power 2, you get 3. 3 times 48, you get your answer to be, so 3 times 48 gives 144. You get 144, and 2 times 3, the root of 3 to the power 4 is just the same as you multiply the root of 3 4 times. And then that will give you 9. 9 times 2, you get 18. And then when you add everything, if you add properly, I think you get something like 194 as your answer. So this is what you're going to get as your answer. Yes, you get 194 as your answer. So we move on to the next slide. Example 8. Find the 5th and the 6th terms in the expansion of that. Let me just see these people are raising their hands.
Sir,
Yeah.
can we just go back a bit before we go to example 8?
Okay.
What if they are different powers? They're not the same. From where it says hence simplify and also find the exact value of those same equations. What if the powers are not the same?
When the powers are not the same, and then there has to be
Yes.
a way in which you can make the powers the same. But normally they don't ask such questions. They will ask you a question when the powers are the same. Yeah, they can even ask you to say, they can even give you a question when the powers are not the same. But if you encounter such a question, just know that there's a way you can manipulate the question to make the powers the same. You understand?
Okay.
All right.
Yes.
All right. So, Alili, okay, Alili, you can speak.
Oh no, I don't have a question. Sorry.
You don't have a question? All right. Yeah, you can now write the formula. So from after that, you can now write the formula. The formula is when you are finding the nth term, I'll call it the nth term. In some books, they write it as the rth term. So I'll call it the nth term. You use this formula here. N, choose R, and then and then you say N minus R, and then B, sorry, let me just write it properly. B, R. So this is how you find the nth term. So now it is just a matter of replacing the values there. So your n there is 10. Saying 10, choose R. What is R? So on R, that's why a lot of people miss it. So when finding R, remember what we said. In any given expansion, there are n plus 1 terms. So meaning the first term, yeah, there are n plus 1 terms. So if there are n plus 1 terms, if this is raised to power 10, and then they are asking us to find the fifth root, it means that for you to find R on the fifth root, R is equal to n, oh sorry, yeah, it is equal to the nth term, that term that we've been asked to find, and then minus 1. So for the fifth root, sorry, for the fifth term, the value of R is going to be n. So the nth term there, we've been told to find the fifth term. So we're going to say 5 minus 1. So the value of R is going to be 4. So for the fifth root, for the fifth term, the value of R is 5 minus 1, which is 4. So I'm going to put my 4 there. And then the A that I found is 2x. The A that I found is 2x. 2x to the power n minus R, so it's just the same as 10 minus 4, which is 6. And then, so I'm finding the fifth root, the fifth term. I don't know why I'm talking about the roots. Complex numbers are a problem. Anyway, So 10 minus 4, you get 6, and then you multiply this with BR. Which one is my B? My B is negative half. So my B is negative half, and then raised to power R, which is 4. So as simple as this, you just now need to simplify this. So in simplifying this, what you do is you say 10, you write 10 there on top. Before you start putting the factorials, you subtract 10 minus 4, you get your 6 factorial. So I'm going to move 10 to 6. So 10 times 9 times 8 times 7, then times 6 factorial, like that. I want this 6 factorial to come and cancel with that. And then you multiply by 4 factorial there. So that and that will cancel. Then everything multiplied by 2x to the power 6, and then multiplied by negative 1 over 2 to the power 4, like that. So when you simplify this 4 factorial is just the same as 4, just the same as 4 times 3 times 2, then times 1. Then you begin to divide 2 into 8, you get your 4. And then 3 into 9, you get your 3. You're just reducing the numbers. And then this 4 can cancel with that 4. Then you multiply now 10 times 7, you get your 70. 70 times everything this side. After simplifying, you get your answer. So this is what I'm talking about. This is what I'm talking about here. You use this formula. Then you find your R for the fourth term and the R for the sixth term. R is equal to the nth term minus 1. Then the fifth term is given by that. Then you solve. This is what I was just doing. Okay. All right. So you finish it up like that. So this is your fifth term. This is your sixth term. After simplifying, these are the answers that you'll get. We proceed. So this is question 6 now, tutorial sheet 1. We are saying determine the sixth term in the expansion of 3x plus y over 3. So determine the sixth term in the expansion of 3x plus y over 3. So this one is very much straightforward. It's just the same way we're just from doing the first part here. So finding the sixth term, you first find your R. How do you find your R? We said R is equal to, since we've been taught to find the sixth term, you say 6 minus 1. So the value of R there will get 5. Then you replace in the formula, we're finding the sixth term. So the sixth term will be given by the formula is here, n choose R. So n, my n there is 13. So 13 choose R, which is my R is 5. And then my A will be 3x here. This is going to be my A. 3x raised to power, oh sorry, this is 5, not R. Let me write 5. Okay, this is 5. Okay. And then the A there that we have is 3x. So 3x, 3x to the power 13 minus 5. So 13 minus 5, you get your 8 there. And then my b is y over 3. This one, my b is y over 3, and then raised to the power r, which is 5. Then when you simplify everything there, you get your answer to be this. So this is going to be your answer after simplifying. So we move on to the next question on the same question 6. They're saying determine the middle term of this expansion. So when you expand this, how many terms are you going to have? That is the first thing that should come in your mind when you see such a question. So when you expand this, how many terms are you going to have? So when I expand this, I'm going to have n plus 1 terms. So what is my n? My n is 8. My n is 8. So plus 1. So in the expansion of this, I have 9 terms. And then they are asking me to find the middle term. How do I do that? Finding the middle term, you can even write numbers from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then you start cancelling them from this side. You cancel one there, you cancel one there. This is just the simplest way, the easiest way you can understand this. You cancel there, you cancel there, you cancel there, you cancel there. So our middle term is the 5th term. So if our middle term is the 5th term, you discover that your R now is going to be, your R is going to be, your R on the 5th term is going to be 5 minus 4, oh sorry, 5 minus 1, which is 4. Then you replace all your values. This is going to be your A. So your A is going to be 2x. Then your B is going to be negative 5z. It's going to be negative 5z. And then your N is going to be 8. And then you replace them. You replace all these values in this formula there. So once you replace them in the formula, you find your final answers. So after finding the final answer, you discover that your answer is going to give you this, which is 700,000 x to the power 4 and z to the power 4. This is going to be your final answer. So on the same question, question 6, we have this question which is saying determine the term independent of x in the expansion of negative 1 over that. Let me just delete this. So they are saying determine the term independent of x in the expansion of this. So on this one, you should pay attentive, listen to me clearly. So when finding the term independent of x, time is almost done. It's almost up. We're just remaining with 8 minutes. Okay, let's see what we can do in these 8 minutes. So when you're finding the term independent of x, if finding the term independent of x, you're simply finding the term that has no x value. And how do you do that? I'll solve it just here. So the term independent of x is found by, first you write the formula for the nth term. Actually, the formula is already here. So, okay, let me just rewrite it here. So it's going to be like this. N, choose R, and then you have A, N minus R, and then you have B, R. So for the term independent of x, we are going to have n to be equal to all this. This is the nth term. So now it is just a matter of replacing things there. Your n there is 15 in this question. So your n there is 15. So N is 15, choose R. You don't know your R, so you just write R there. And then the value of A there that have been given is X. X raised to the power 15 minus R. I don't know my R. And then I'll multiply everything with 1 over 2, or this has to be negative 1 over 2x squared, like that. And then is R. So in short, for this term to be independent of x, the term to, if they ask you to find the term independent of x, they are simply asking you to find the term that has no variable x. So any term, when I say 2x to the power 0, 2x to the power 0, this is just the same as 2. So in short, I will equate this, the variables of x. Okay, in short, yeah, all right. I'll equate this variable of x, which is x15 minus r, and then dot, this is multiplication, and then this, I'll just get the variables of x. So this x squared, 1 over x squared, I can also write it as 1 to the power negative 2, 1 to the, x to the power negative 2. So this, I'll equate it to x to the power 0, because I want to get rid of that x. So since the bases are the same, meaning of the powers are also the same, I'm going to have this 15 minus r minus 2. Oh, sorry, this r is also multiplying with everything in the brackets there. So this is going to be r. So minus 2r is equal to 0. So apart from this, we're going to have when you simplify this, you're going to have 3r is equal to 15. When you simplify this, now since the time is almost up, that's the reason why I'm skipping some steps. But I think the next time we meet, we'll start from this same question. I'll explain more things about this question and how they are brought in the exams. And trust me, once I teach you how to answer this question, you never get it wrong. So you find your value of R to be 5. So for you to find the term independent of x in this expansion, you just replace this R in the general formula that you formulated, which is this one here. So you just replace the value of R in this expression here. When you replace it, you find your answer to be 3003 over 32, and let's see, the 6 is a term that is independent of x. So thank you very much for watching. See you next week. But before we close the meeting, let me first allow a few questions. If you have any questions, please, you can ask. If you have any questions, you can ask. Let me just try to unmute all of you. Hello. So if you have any questions, please, you can ask. Aline, do you have a question?
No, I don't think so.
All right. Nalishevo, do you have a question? Mwandwe, do you have any question? Kabaso?
No.
Do you have
No,
any question?
I don't.
All right. Donald, do you have any questions? Donald, do you have a question?
I'm saying no, I'm good. Thank you.
All right. And then Ruth, any questions? Ruth? Okay. Anyway, you guys, see you next time. So I'll share the slide, and then I'll advise you to go through it before we come and start the extension of the binomial theorem. So I'll be, as I earlier on said, I'll be sending the slides. You'll be going through them, and also the video, the recording. I'll be sending them in the group. And then apart from that, I'll also be advising you to ask questions where you are not clear. When you are going through the slide, you find a point where you're not clear, you can simply inbox me. Or when you're going through any questions, even something that is not even in the tutorial sheet, you can simply just capture the question and forward it to me, and I'll help you to solve that question. Thank you very much, you guys. See you on Wednesday in our next meeting. So I'm leaving the meeting.